Okay, good morning, friends. Now, as you know, you are attending this online class on fifth SEM elective, that is crop production. Now, we have six classes. Today is the first class. On Saturday, we have, on Sunday, we have, and again on 18, 25, and last class will be the first Sunday of March. So, in all, we have six classes allotted for this crop production. And coming to this syllabus of this crop production, this syllabus has been put into two blocks. One is soil fertility, tillage, and weed control. This is the first block or first part of your syllabus. And the second block consists of crop production, wherein we discuss about various crops such as cereals, millets, starting from rice, wheat, maize, then millets, sorghum, bajra, ragi, and korra. Then we have oil seeds, groundnut, castor oil, sesame oil, sunflower oil, safflower oil. Then we have pulses, black gram, green gram, red gram, Bengal gram, etc. Then in our fifth, online class, we'll deal about the cash crops. That is the crops which are primarily grown for cash. That is to meet the cash requirements or economic requirements of a farmer. Farmer not only grows food crops, pulses, oilseeds, but also to meet his financial requirements, he grows or he goes for the cultivation of sugarcane, cotton, tobacco, chilies, and dhania is there, ginger, turmeric, etc. These fall under what we call cash crops. And the last class, that is sixth online class, will be mainly on orchards. That is mango cultivation, citrus, then cashew nut, and the coconut. So this is the syllabus, and we will be completing this syllabus in six classes. And this class duration is 1 hour. And in today's class, we confine ourselves to agricultural meteorology, then soils, and also the manures and fertilizers. So these are the three units which we will we will be dealing with, and I'll be explaining you about the importance and the manner and the methods of these three units. To begin with, agricultural meteorology. So agricultural meteorology means, simply speaking, the climatic conditions existing in a particular area. So what type of climatic conditions exist in a particular area, determines, influences the type of crop for which the farmer would grow, or the climate primarily influences, whether it should be a kharif crop, a rabi crop, or a summer crop. So all these are determined by the various climatic conditions that are existing in a particular area. I think you know the difference between a climate and weather. Generally, climate generally speaks about the lengthy period, that is a larger area and the larger span of time. So what type of climatic conditions exist in America? What type of climatic conditions exist in Europe? What type of climatic conditions are prevalent in India? So this tells you what is the broad seasons and the duration of rainy season, winter season, and summer season, etc., and the minimum and maximum temperatures, and the intensity of the light, and the duration of the light, that is the relative length of the day and the night, etc. These and the relative humidity in that area, and what type of wind speed and wind and cyclonic storms, and the most important rainfall, etc. All these put together will tell you about the type of climatic conditions prevalent in a particular area. Now, coming to weather, generally you might have heard about this weather. If you tune to what we call news bulletins, generally at the end of the news bulletin, they'll tell you the weather, they say. So weather, you might have seen. So what is the minimum temperature and maximum temperature and the relative humidity and the rainfall, etc., will be forecasted. Weather, generally, this confines to what we call a short period of time, that is in a 24 hours. In the coming 24 hours, what type of weather is likely to prevalent in that particular area? See, for example, this generally people who are interested in sports and games. For example, now the cricket match is going on. England and US. I mean India, in England and US, India. This match is being played in Vizag. So generally, what type of weather conditions prevail there? Is there any scope for the rainfall, etc.? This will be forecasted by the weatherman, and according to that, the players or the people who are interested in conducting those matches, etc., will take precautions. So weather means generally it tells you about the climatic conditions exist in a shorter area. That is, for example, what type of weather is likely in Hyderabad in the coming 24 hours. So shorter duration and shorter area, average, you know, average, temperatures, average humidity, and the rainfall, etc. So this is, weather conditions. So the climatology, this is the science that deals with, average atmospheric conditions that are prevalent in that particular area. So now in this, climatology or agricultural meteorology, we confine ourselves. It is a big subject, it's a big subject, but we are concerned with the important parameters that influence our crops. So generally in this agriculture meteorology, we'll discuss about 4 or 5 important components of this. One is solar radiation, temperature, the atmospheric pressure, the wind movement, the relative humidity, evaporation, clouds, and rainfall. So we'll discuss about this one after the other. So first of all, solar radiation. Solar radiation is nothing. What do you mean by solar radiation? That is sunlight. So sun, the entire energy for our planet comes from sun. Sun is the ultimate source of energy. Sun is the ultimate source of energy, and sun, the energy, that is light. Light comes from sun in the form of electromagnetic waves. Electromagnetic waves are in the form of what we call photons, or the particles. So particular nature and wave nature. This is the important importance about sunlight. Now coming to the sunlight, sun emits light in the form of particles and in the form of wavelengths. So now this of the total sunlight that our planet Earth gets, only 47% of the light that comes from sun in the form of radiation will be absorbed by the Earth's surface, and the rest is reflected back into the space. So roughly, 53% gets reflected back into the space, especially clouds and the particulate matter and what we call the uh, water drops or water vapor that is present in the atmosphere. They reflect about 53% of the radiation that is coming from sun. So only 47% will be absorbed by the earth. Now, when when earth absorbs this light, it gets hot up. The surface gets heated up, and the earth is covered by, our earth has its own atmosphere. So atmosphere is nothing but various types of gases. So these gases, they get hot up. So when they get heated, they tend to move up. So when light rays touch the surface of the earth, it gets heated. Now this heat uh, is the source for the temperature. So the energy, that is temperature of the earth, the reason or the temperature is nothing but it is the resultant of radiant energy that comes from the sun. So now uh, this light, light is a very, very important factor. If there is no light, there is no scope for the life to exist on this planet. Because uh, plants, plants are the important organisms which provide basic needs for human exist. The sustenance of human life is because of the presence of plants. And plants need light. If no light, no plants. If light is not there, there is no scope for the plants to exist. And now this light, whatever the light that comes from the sun, it will be absorbed by the that is even in tanks, your seas, your rivers, etc., all have what we call aquatic biota. That is algae, which is dispersed in the water bodies, and they absorb whatever the radiant energy that comes from the sun, and they do what we call an important biological phenomenon, physiological phenomenon, that is photosynthesis. Photo means light, synthesis means production. So plants, green plants, are chlorophyll containing green parts. They convert this radiant energy into chemical energy. So conversion of radiant energy, conversion of light energy into chemical energy is nothing but photosynthesis. And as a result of photosynthesis, we get two important end products. One is the carbohydrate or the sugar. The other is oxygen. These two are the very, very important end products of photosynthesis. The entire plant, the entire, life on this universe directly or indirectly depends on the photosynthate, that is sugar. And of course, for all organisms, you and me, we need oxygen. So this oxygen is the resultant of our photosynthesis. So we absorb this oxygen, and of course, we use it for what we call respiration, and we release all living organisms release carbon dioxide at the end of what we call respiration. And of course, this carbon dioxide will be taken in by all green plants, and they utilize this carbon dioxide in photosynthesis. So this is a continuous process. So here, coming to the importance of light, now this light, very, very important for photosynthesis. So even for the formation of chlorophyll pigment, light is very much needed. So now coming to the light, the light, various parameters of light. That is the intensity of the light, the quality of the light, the duration of the light do matters, do influences various physiological processes of what we call plants. The if the intensity, what do you mean by intensity? If the intensity is high, it adds to the rise of temperature. If the intensity is very low, that is feeble light, generally temperature will be low. Now, not only the intensity, but the quality of the light also matters. Whenever I say quality, what do you mean by that? When light rays pass through a prism, you studied about this in your physics class, even in high schools. No, the light ray gets dispersed. It splits into 7 colors, what we call VIBGR. So violet, indigo, blue, etc. Right. So this violet has low wavelength, red has maximum wavelength. Whereas, the coming to the quality, those 7 colors are there. Red is the pigment, the most important wavelength that is useful for the photosynthesis. Now, blue light, even violet also helps in photosynthesis. But you'll be surprised, though plants look green, but the green part of the VGR, that is green light, is not at all helpful for the photosynthesis. So what I mean to say here is the intensity of the light, even the quality of the light also matters in the plant growth, plant yield, etc. Now coming to the, not only this, even the duration of the light also matters, influences, you know, uh, plant growth and development, or crop growth and development. So what do you mean by this duration? Based on the relative lengths of day and night, the plants are classified into 3 categories. So this influence of the day, relative day and length on the plant is what we call photoperiodism. So based on the photoperiodism, or based on the requirements of day and night, relatively, plants are classified into 3 categories. That is long day plants, short day plants, day neutral plants. Long day plants means they require more than 12 hours or so. Such plants which require more duration of light than the dark, they're called long day. The name itself tells you they need long days. That means short nights. The other are short day plants. That is, they need shorter duration of the day, but lengthier duration of nights. Day neutral plants, they are not at all influenced. They don't have any marked influence on their physiological, activities and growth and development and yield. Such plants are called day neutral plants. So such like that, the long day plants, whenever I say long day plants, beetroot is an example, or your spinach is an example, or what we call radish is an example, barley, wheat. These are some of the long day plants. Short day plants, for example, tobacco is there, xanthium is there, our chrysanthemum are there, even soya bean. These are some of the short day plants. And there are certain plants which are called as day neutral plants. They have no effect on their growth and development, the relative length of day and night. Such plants, day neutral. They don't have any influence. Such are called day neutral. A good example for this is what we call cucumbers, maize, etc. They are called day neutral plants. Now, what is the effect, So generally, these plants, the not only for photosynthesis, but, the temperature of the atmosphere is regulated by the intensity and the duration of the light. And, for the seed germination, light is needed. Even for what we call for the birds to flower initiation, or bud or flower initiation is influenced by the light. Even the temperature are influenced. Even the seed growth Seed growth. Certain seeds, they germinate in dark. Certain seeds require light for their germination. So like this, light has immense effect on the growth and development of, or on the life cycle of plants. Okay. Now, then we move to what we call the second parameter of the climatic conditions or agriculture meteorology, that is temperature. Now, see, light, whenever they are asked, sometimes they'll ask you under, objective type, which is the instrument that is used to measure light intensity, or for the instrument that is in measures light is known as pyrheliometer or faranometer. This is the instrument that measures light. Okay, so you'll be surprised, plants utilize only 1% of the light energy. So 99%. So even if a plant gets exposed to a maximum amount of energy or light, it uses only 1% of the light. For doing its photosynthesis, it requires that it uses only little amount of light. Then, of course, coming to the second parameter, that is temperature. Temperature, whenever we say temperature, so I think the temperature. See, the temperature, minimum, maximum temperatures, even the temperature has a profound effect on the, various stages of plant growth and development. Generally, to measure, temperature of the atmosphere or your body temperature, we make use of what we call thermometer. Of course, there are two common scales you are acquainted with. This one is what we call Fahrenheit. The other is what we call centigrade. So see, our body temperature, normal, a healthy man's body temperature is 37 degrees centigrade, which is equivalent to 98.5 degree Fahrenheit. So generally, thermometer generally is used to measure the temperature. Now, the effects of temperature on plant. So plants need what we call minimum temperature, maximum temperature, and optimum temperature. For various physiological activities to take place in plant body, it needs ideal temperature. Ideal temperature, what we call optimum temperature. So optimum temperature. So generally, various, say for example, the tuber forming crops, such as your, beetroots or your, potatoes. Generally, you get, if the climate, if the cool nights are prevalent in a particular area, generally the yield will be more. The tubers, the potato tubers you get, or the beetroot tubes that is you get, will be of larger size. So for higher yields of potatoes and beetroots, we need what we call cool nights. And whereas the other, that is, for example, for maize and for the cotton, etc., for their maturation and for the higher yields, maize, cotton, and tobacco, they need what we call warm nights. So some crops need cooler nights, some other crops need warm nights. So the temperature, direct temperature is very, very essential. If the temperature falls to, 3 to 4 degrees centigrade or 0 degrees centigrade, generally it affects plant growth and development. Even the seed germination, for the seed to germinate, it needs, generally, depending on the variety or the crop type, generally, ideal temperature for the seed germination will be around 15 to 20 degrees centigrade. If it is below 10 degrees centigrade, generally, the seed fails to germinate. Even for the higher rate of cell division, cell elongation, and growth, plant needs ideal temperature. So ideal temperature, optimum temperature will be around 20-25 degrees centigrade is the ideal temperature for the healthy growth and the higher yields of crop plants. So generally, if it falls, below 0 degrees centigrade or so, it leads to what we call, um, uh, even in the cytoplasm, the water that is there, it turns to what we call, crystals. That is freezing. Now, this leads to what we call chilling injury. The chilling injury is also very, very dangerous. If the temperature falls markedly, generally, it leads to formation of what we call certain spots or the bands on the leaves. Even there is a fruit drop will also be there. Even on the fruit also, you will see spots. So temperature is also another very, very important factor. Now, coming to the other factor is pressure, of course. Atmospheric pressure has an indirect effect, of course. Generally, the pressure, generally as you go up. So for each around, for every 1,000 feet height, the temperature or the pressure falls by, by 1 inch of mercury. As you go up, if you go to, Himalayas or higher mountainous regions, generally the pressure will be low and you feel restless. We feel difficulty in taking breathe. So generally, the instrument that is used to measure pressure, atmospheric pressure, will be what we call a barometer. Then wind movement, of course, wind is also another climatic or weather factor that influences plant growth or crop growth and development. Generally, in wind influences, even the temperature of an area, even the pressure of an area are influenced by the wind. Wind is very, very important. Generally, if the wind, there is a gentle wind. If the wind blows gently, generally, the rate of photosynthesis will be more. Even the exchange of gases will be more. But if there is a gust of wind, if the wind blowing with higher speed, that is very dangerous. If higher winds blow, generally, the stomata that are there, they get closed. So no exchange will be there and the photosynthesis gets affected. Even if there are winds blowing at maximum speed, they cause a lot of damage, even for the standing crop. Even they will uproot even big, big trees. And there will be what we call lodging, that is felling. Even there is a breakage of what we call crop stalks. Even the head, that is seeds are there. If there is a gust of wind, there is every possibility for the shedding of those seeds. So a lot of damage will be there. Generally when there are cyclones, cyclones, not only the rain, but even the highly blowing winds or the winds that are blowing at a higher speed will cause greater damage. So the wind movement also an important parameter. And generally, wind, there are two instruments, one is what we call wind vane. You might have seen on the high-rise buildings, you will see certain arrow-like projection, a small instrument. It shows, which direction the air is blowing or air is moving. And there is to measure the velocity or at what speed, in weather condition, they'll tell you the if the weather is very rough, if cyclonic storms are expected, they'll tell you, so wind speed would be some 50 to 60, kilometers per hour. Or if it crosses, at the time when the cyclonic storm reaches shores, it will range from 100 to 150 kilometers per hour. If such a high speed winds, occur in a given area, they cause a lot of damage, uprooting of big, big trees. There is a breakage of, what we call, branches. Even your power lines get affected, power gets affected. So you remember this wind vane, which helps you to know the direction in which the wind is blowing, and the wind velocity is known by what we call wind velocity pan, or what we call anemometer. Anemo means related to air. Now, effects of wind on crop growth, already told you. Generally, they help, what we call for for the germination, for the for greater photosynthesis to take place, even for what we call pollination. For pollination, wind pollination, wind takes the pollen along with it, and the pollen may get transmitted by blowing winds, and it will be taken onto the stigma of the other, related plant. So cross pollination, what we call. So for pollination, for even for if harvest is there, to remove the chaff or the unfilled grains, generally winnowing is done. So this wind we use, and nowadays, the alternate sources of energy, wind mills are there. Windmills are there. They generate energy. So now, if wind blows, I already told you, it leads to what we call lodging, breaking of stock, shedding of grain, etc. Even felling or unripe fruit. Of course, this generally, in the months of April and May, during the summer, you will see pre-monsoons. If pre-monsoon showers are there, if there are gust of winds, they leads to lot of damage of, especially mangoes, etc., which are ready for harvest. Lot of damage will be there if wind blows at a higher speed. So then humidity, of course, the wetness of the air, that humidity, the humidity is also very, very important. And if the humidity of the atmosphere is more, or if the humidity of the soil is more, generally uh, plants, a requirement of water will be less. If the weather is very dry, if humidity is very less, generally under such conditions, the transpiration will be more, and the plants' water requirements will be more. So humidity also plays an important role. If the humidity is, of course, I told you, if the humidity is less, that is good for the crop, because a lot of humidity is there and plants' water requirements will be less. But the other side is, if the humidity is very low, if the weather is cloudy, in such a cases, the pests and pathogens, the insects or our, fungal, bacterial diseases spread very fast. They cause a lot of damage. So humidity effects on crop growth are very, very important. And then what we call, after this, we will study about clouds and rainfall. Cloud is nothing but when the sun rays hit. I told you, surface. The it will be reflected back. When it reflected back, the air that is there, it gets hot up, and the heated air becomes light and moves up. And this vertical movement of the air and the horizontal movement of the air, that is wind blowing. And these horizontal and vertical movements, they are responsible for what we call the rainfall to occur. The rainfall or the cyclonic storms. Cyclone is nothing but, when there is a low pressure, the wind from the, higher areas move to the lower area, or the pressure from the higher pressure areas to lower pressure areas. Then you will see whirl or tornadoes, etc. Generate tornadoes whenever we call up this. These are very, very common in countries like US, etc. They cause a lot of damage. So rainfall, rain is the other very, very important factor for the plant growth and development. And this rains, generally there are three types of rains are there. Rains due to what we call convection, rains due to cyclones, and rains due to mountain barriers. Rains due to convection means, see, whatever the humidity, In the humidity is nothing, but in the clouds, what do you find? So small water vapor, water drops are there. These water drops, they come together, and when they coalesce, when they fuse, it becomes a bigger. If the size becomes more than 0.25 um, and then it comes down in the form of rain. So the rain that occurs because of the coalescence of these water drops that are present in the clouds, that rain we call a rain due to convection, and a rain due to cyclones, generally, I told you, because of depression, generally from higher velocity to lower velocity, from higher pressure areas to lower pressure areas when the wind comes, and this vertical movement of the wind or hot up winds, they create what we call cyclones. And under this cyclonic effect, rains we expect, and generally cyclones generally we are expected in the regions which are very, very near to seashores. And of course, the third is mountain barriers. So when the wind is blowing, when the wind is blowing, and the natural barriers are our mountains. The wind blows, and the mountain, they go and get stopped at the mountain region. And generally, whenever it stops, there the temperature falls, and under this fallen temperature, the water drops that are there in the blowing wind, they fuse and comes down in the form of rain. And generally, rain is measured by what we call rain gauge is there. And this rain gauge helps the rain generally expressed in the form of centimeters and millimeters. You know this. Then effect of the rain, generally rains are very, very important, based on the rain only, rainfall only, we take up various types of cultivation. Generally in the equatorial region, generally we expect more rains, temperatures will be high, rainfall will be very high. And in those areas, even the soils are very fertile, and the luxuriant growth of forests, you will see evergreen forests generally occur on other side of the equator. And in the polar regions, as you go to the poles, generally the temperature will be very low, and in such cases, only special types of forests, generally gymnospermous plants, which are able to, face these cold climatic conditions, are able to survive. And apart from this, generally the rainfall, if the rainfall is very, very heavy, of course, heavy rains are very ideal, but if the rainfall is very, very heavy, and it lasts for a longer time, it washes away the topsoil. This removal of the topsoil, what we call soil erosion. And this leads to loss of, fertile soil. And this, soil that will be lifted will get deposited in the reservoirs, and the reservoir capacity gets lessened because of the deposition of this silt. So, and when there are rains, generally if there is a stagnation, inundation of the area, there is a leaching of, minerals. So whatever the minerals that are there in the soil, they get leached, they move deeper areas. This is not at all a desirable thing. So even rainfall also, moderate rains are very, very ideal. If the rainfall is very less, drier areas, our Sahara and Thar deserts, where the rainfall is very, very less, and such conditions we call desert areas. If the rainfall is very less, no rainfall is there, in such cases, the vegetation will be very, very meager vegetation will be there. So this is about what we call meteorology, that is climatic conditions. Then we move to soils. So now soils, soil, what is soil? Soil is nothing but the top layer of the earth, top layers of the earth, which are very, very rich. Which is the richest thing in the world, soil, not the gold or the platinum. Soil is the richest, a resource, because it has the ability to produce crops after the crops for thousands of years. But your platinum and gold, they never get doubled. But our sustenance of human life is only because of this fertile soils. And this soil, these soils are very, very precious. And you have to remember this soil, the top layer of the soil, uh, for the formation of 1 inch of the soil, 1 inch of the soil, it takes 500 to 1,000 years. It's a very, very important resource. Based on the soil or soil fertility, the human settlements will be there. The deltoic soils, wherever the deltas are there, if you take the demographic, characteristics of India, most of the people are living in the Gangetic plains, where the Ganges flows. So from Uttar Pradesh to Bihar and Bengal, where along the sides of Ganges, there are lots of settlements, lot of people live because those soils are very rich. They support the growth of various crops. So you get a lot of water. So hence settlements are more. Even if you take our area, so in combined Andhra Pradesh generally, people are more in Godavari districts, in Godavari, Krishna and Guntur, where various rivers flow. So so even in eastern, western and southern, wherever you go, generally, wherever the deltoic soils are there, which are very rich, which are very fertile, which support the luxuriant growth of various crops there. The settlements are more people live there. Now coming to the soils, soils primarily three types of soils are there. Primarily, one is sandy soils, the second is alluvial soils, the other is clay soils. Sandy soils means generally you find the sandy soils in the areas where there is a scanty rainfall, where the rainfall is very less, where the temperatures are very high. In those areas, generally you see sands, and the sandy soils are not at all preferable because their water holding capacity is very less and their organic content is very less, humus content is very less, and the microflora that are present in the sands are very less. Hence, they do not support various crops. Only few crops such as castor or bajra or your cashew nut, etc., are expected in those infertile or sandy soils. Now, coming to the silt soils or alluvial soils. Silt or alluvial, they are nothing but deltoic soils along. So when the river flows, when it divides into two, and whatever the silt it carries, it deposits in there. And that silt is very, very rich in minerals. And that soil is very, very good for the crop cultivation. So generally, you come across these alluvial soils or deltoic soils in the rivers of what we call Ganga, Yamuna, and Godavari, Krishna, Kaveri. These are the Narmada. These are the areas where you will, or Mahanadi. These are the areas along the sides of these rivers. You find what we call alluvial soils, which are very, very good. And the third one is what we call clay soils, or what we call black cotton soils. These black cotton soils are they are found in the central India and in southern Deccan Plateau areas. You come across these clay soils. As the name indicates, black cotton soil. Their water holding capacity is very, very more, and they support they supply uh, moisture to the growing crop, and generally cotton is the preferable crop in this clayey soils. And this there is fourth type of soil, which contains what we call sand, clay, and silt in equal proportions. Such soils are called loam soils. Loam is very, very important for you. So, which of the following is the most fertile soil, most you know uh, um, preferable soil type? Means loam soil, wherein sand and clay content is almost equal in proportions. If the soil, if sandy soil, sand is there, its water holding capacity, its microflora less, but porosity is more. That is the air, because in the sandy particles, between the soil particles, you see soil air, soil microflora will be there. Whereas in case of silt soils or in the black cotton soils, the clay particles are very closely packed. So there, the porosity is very, very less. If the porosity is very, very less, the content of the oxygen content is very less, and even the microflora content is also very, very less. So primarily the sandy soils, silt soils, clay soils, and loamy soils, these are the primary soils. So apart from this, even we have what we call dubba or chalka soils are also there. Dubba soils, which are very, very shallow. These very shallow soils, and generally the salt content will be there. Mostly they are alkaline soils, and generally these are not fertile. But of course, the soil that is sandy and chalka soils, there generally people grow for, or farmers grow jowar, bajra, red gram, castor, etc. in those areas. And generally, I told you these loam soils are very, very important. And crops, jowar, bajra, ragi, and even sugarcane, rice, etc., are grown in those areas. And black cotton soils already, regurs or regadi, nailal, what we call. Generally, these are prevalent. And as far as United Andhra Pradesh or Telangana are concerned, generally North Telangana, generally Adilabad, Nizamabad, Warangal, Khammam, these are the areas where you find black cotton soils. And coming to Andhra, generally Karnool, Anantapur, Nellore, and Guntur, they have this black cotton soils. And generally in black cotton areas, apart from cotton, even jowar, bajra, pulses, cotton, tobacco, groundnut, etc. are grown. If the irrigation facilities are there, generally farmers take up what we call rice and sugar cane. Generally, these black cotton soils, they are very deep soils. So the deep depth, ranges from 90 to 180 degrees, and their water holding capacity is more, I told you. And generally, they not need frequent rains. 1 or 2 rains are sufficient. They support the growing crop. But the only thing is, if they get flooded, if more rains are there, generally it leads to stagnation, and which ultimately leads to what we call the um, you know um, the root system doesn't get the required amount of oxygen, so it leads to death of the root system. So though its water holding capacity is more, but because of the less porosity and the less exchange is possible, and this root system gets died because of the toxic effects, because of the inundation leads to toxicity. So now, what we call, certain problematic soils. This is also important for you. Problematic soils are soils which are not normal. Here, the soil pH is either too low or too high. And such soils which are not at all congenial for, crop growth, unless you take up what we call amendments, unless you go for reclamation of those problematic soils, the cultivation of those soils is very, very difficult. Generally, these problematic soils are primarily of two types: what is acidic soils and alkaline soils or saline soils. Acidic soils generally you come across in the areas where there is a lot of rainfall. Generally in the eastern Ghats and in the western Ghats areas, especially in the northeast, especially in Assam, Manipur, Tripura, West Bengal areas, parts of Bihar, Maharashtra, Karnataka, Tamil Nadu, there lot of rainfall is there. If the rainfall, average rainfall will be more than 200 centimeters in a given season. Such high rains are there in those areas, because there is a lot of inundation, leads to what we call toxicity of the soils. So that leads to falling of the pH. pH will be less than 7. If the pH is less than 7, we call acidic soils. If the pH is more than 7, we call basic soil or alkaline soils. So to reclaim, if the soil is acidic, generally what we do, we go for reclamation. In reclamation, what we do, you add limestone. So generally calcium alone or calcium magnesium containing lime is added, lime is powdered, and that will be spread in those soils. And they uh, bring up the pH level of those soils, and soil becomes normal, and you can take up, crop growth. So the second is what we call alkaline soils, where these alkaline soils can be reclaimed. you can reclaim those saline or alkaline soils by applying what we call certain things such as gypsum, calcium sulfate, etc. You can add, wherein it exchanges. There is an exchange of sodium, which is the responsible for salinity. You remove that sodium salts by supplying calcium. So calcium replaces your sodium, and thus your alkaline or saline soil becomes normal, and you can take up cultivation. So this is what we call reclamation. So saline soils or alkaline soils are reclaimed by addition of gypsum, whereas acidic soils are reclaimed by adding what we call limestone. Then loss of soil fertility. Fertility is nothing but what is the soil fertility? The ability of the soil, innate ability of the soil to supply required nutrients at the required time for the crop to grow and give high yields. Such soils are called, fertile soils. Then crop productivity is the ability of that particular piece of land to yield, to give higher yields. That is the productivity. So generally, for the productivity or for the soil fertility, generally what we need to add fertilizers. Fertilizers are added um, to cope with the loss of fertility. So how do soils become infertile? If you go on cultivating, and cultivating year after year, if you do not add any additives to the soil, generally soil becomes infertile. So, uh, so this fertility is lost mainly because of continuous growth and harvest of the, and even uh, what we call the weeds. Weeds to do take up the nutrients from the soil, and thus they lead to what we call loss of fertility of the soil. And not only that, I told you, if there is a heavy rain, if the flooding takes place, the nutrients get leached. Leaching means they move deeper into the areas of the soil, and your root zone will not. They go beyond the root zone, so the crop will not be in a position to absorb those nutrients. So loss by crop plants, loss by what we call weeds, and loss by what we call leaching. These are the factors that are responsible for infertility of the given soil. So now, how you can reclaim those? How you can reclaim those? Or how do you enrich the soil fertility? The soil fertility can be done by cultural practices, by adding nutrient rich manures, and by taking up what we call biofertilizers. You can enrich, or you can add to the fertility of the soil. So cultural practices means agricultural practices. So generally, instead of how fertility is lost, I told you, continuous growing. If you go on growing, so fertility loss. So what do you do? Instead of cultivating, you go for what you call fallowing. Fallowing means for 1 or 2 years or 1 or 2 seasons, you don't grow any crop. So during that period, it replenishes. It gets whatever the important minerals it lost by natural process. It gets recouped. This is what we call fallowing, and the other is what we call crop rotation. Crop rotation is the another important agricultural activity which counters your loss of fertility. So here crop rotation is rotating a cereal crop with a pulse crop. 1 season or 1 year you go, you grow, you take up a cereal. In the next, instead of growing a cereal or a millet, you go for what we call pulse. So generally pulses, they have what we call root nodules in their rise. In their nodules, they have what rhizobium, which has the ability to fix atmospheric nitrogen. So this is cultural practices are there, and then you go for addition of what we call organic and inorganic fertilizers. Of course, we'll study about that um, in the next chapter. And the other is what we call biofertilizers. So these biofertilizers are nothing but use of living organisms, living cells, use of living cells or nitrogen fixing microorganisms, either through what we call seed treatment or adding to the soil. You enrich the soil. So use of biofertilizers. This is, of course, we farmers are practicing this, but nowadays the governments are and the agriculture universities are encouraging the farmers to take up what we call biofertilizers in place of what we call chemical fertilizers. Now, generally, the biofertilizer, whenever we say biofertilizers, generally the microorganisms. The microorganisms are of primarily of two kinds. One is free living, the other is symbiotic. Symbiotic means, whenever I say symbiotic, your rhizobium is there, and of course, um, uh, azospirillum is there, and azotobacter are there. Pseudomonas, bacillus are some of the microorganisms, and the other is what we call blue-green algae. These blue-green algae. So blue-green algae like Acylatoria, Nostoc, Cylindrospermum, Alocera. These are the blue-green algae or cyanobacteria that they are free living. They are generally found in the stagnant waters, especially in the rice fields. You will see these, green scums that is seen floating on the surface of the inundated water. They have, these nitrogen fixing able, biological, that is blue-green algae, which convert atmospheric nitrogen into nitrate form. So use of microorganisms to supplement, to enrich the soil is what we call biofertilizers. So symbiotic rhizobium, non-symbiotic azotobacter, and azospirillum, and phosphate solubilizing are Pseudomonas, bacillus, and penicillium, etc. are there. And then soil erosion. Erosion means what? Loss of topsoil is known as soil erosion. Of course, you know this. And this primarily, if the erosion is because of wind, we call wind erosion. If the erosion is because of what we call water, we call it as water erosion. So this wind erosion generally you come across in the Rajasthan and Gujarat areas, generally our western Uttar Pradesh, where you see big sand dunes are there. And if there is a gust of wind, they take away topsoil and they deposit these sands. This what we call wind erosion. And water erosion, of course, water, this water, if there are heavy rains, if the if the soil is not flat, if it is slopy, generally if there are heavy rains, it carries the flowing way, water carries the topsoil. And that we call erosion. And this erosion is of various kinds, but sheet erosion, gully erosion, rill erosion, etc. If it is removed flatly, we call sheet erosion. If it's in the form of a small, channels, we call rill erosion. If these rills unite and form gully erosion. So like this, if because of the erosion, topsoil is removed and the land becomes barren and it becomes unfit for cultivation to take place. So what do we do? Conservation of practices, mechanical, agronomical, and forestry is there. Mechanical means what we do, if the slope areas, you have to construct certain bunds so that if there is a wind, if there is a water, if there is a heavy rainfall, instead of running, water starts walking. So you reduce the speed of the flowing water. So the silt gets deposited in the bunds. This is mechanical. And then agronomical means cultivatory practices. Generally, you go for cultivation along the slopes and you make, certain strip-like trench cultivation stepwise. So there, our main intention is to check the rate of flow of water. Slow down instead of walking, instead of running, water is made to walk. So mechanical. And forest, of course, here what we do is you encourage farmers to go for agroforestry, and as far as possible, Don't leave any barren area. Go for what we call vegetation. This is one, and the crop rotation is there. And these are the practices that help to reduce erosion. And the last, of course, is what we call manures and fertilizers. So manures and fertilizers, of course, I was discussing about the loss of fertility. So what we do in these manures and fertilizers, generally they are divided primarily into three types. One is organic fertilizers, inorganic fertilizers, and biofertilizers. So organic fertilizers means which are organic in nature, and they are primarily bulk and concentrated, and the other is what we call green. That is growing up, fast growing crops and plowing them into the soil. So here organic means generally bulky. So bulky means here what we do, bulky organic is nothing but the farmyard manure. That is farmer, nowadays, of course, we don't find, but traditional farmers have, cows and buffaloes with him. And whatever the cow dung, whatever the cow urine and the grass that is spread as the bed and the remnants of the grass, generally they are taken and they are either put in a heap or in a heap or in a pit, and they will be allowed to remain there for 3-4 months. And in due course, what happens? Uh, it gets digested, and generally you get good manure. So this farmyard manure uh, derived from the cow dung, cow urine, and the remnants of the feed and the sweepings, etc. They are either put in a pit or in the heap, and that gives you what we call farmyard manure. This is organic is in nature. And in addition to this, what we have green manures. Green manure is nothing but you grow fast growing crops such as sunhemp, sesbania, Pillipesceraceae, Phaseolus trilobus, etc. And when they reach the height of 30 or 40 centimeters, then they'll be plowed, and they'll be made to incorporate into the soil, and they get decayed and they enrich the soil. So they enrich the soil not only in the form of giving the required nutrients in required proportions, but also they transform the uh, physical nature of the soil. That is, water holding capacity is enhanced, your porosity gets enhanced, and your microflora gets enhanced. So generally, people are advised, or farmers are advised to go for this, bulky of organic manures. That is, cow dung, etc. is there. Or nowadays, even penning of sheep is there, and poultry, from poultry farms, whatever the excreta of the poultry is there, that is also used as a good manure. And even the sewage and the sludge obtained from the towns, this is also aerated, and this can also be used as a manure. So all these they fall under what we call organic manure. Then coming to inorganic means these are artificial. These are artificial or chemical fertilizers. Artificial fertilizers or chemical fertilizers or inorganic fertilizers are one and the same. And these, generally, they are of primarily of three types. Generally, the fertilizers are of based on the nature of the important component or the principal constituent of that inorganic fertilizer. Generally, the fertilizers are primary of three types: nitrogenous fertilizers, phosphatic fertilizers, and potassic fertilizers. If the nitrogen content is more when compared to phosphorus and potassium, such fertilizer, and fertilizer fertilizer, it is also cyanamide, organic, inorganic fertilizers. Of course, your phosphate generally the soils we have, the rocks we have here, they don't have phosphorus in them. But in certain areas in USA, USSR, and Brazil and Egypt, you find what we call phosphatic rocks. They have high content of phosphorus, and this phosphate is used in the production of what we call muriate of, or rock phosphate, or what we call superphosphate. And the phosphates are of three types. Uh, One we call single superphosphate, and dicalcium superphosphate is there. And we have even tricalcium superphosphate is also there. And in addition to this, we have what we call the potassic, that is muriate of potash, that is calcium, that is potassium chloride is there, potassium sulfate are there, where the element that is potassium is very rich. So nitrogen fertilizers, phosphatic fertilizers, and potassic fertilizers are there. And other are complex fertilizers. Complex means they contain not one, but one or two. A good example for this is DAP, diammonium phosphate. It has both nitrogen and phosphorus together. And generally, these fertilizers are applied, generally, uh, you know, for example, these nitrogen fertilizers are given to the crop in splits, not at a time, in splits. That is, one third is added to the field, and one third when the crop comes for flowering, etc., and when the filling stage is there, the third split is given. Whereas phosphates and potassic fertilizers are given only in one dose. Then, of course, for biofertilizer, I already told you. Then we have soil amendments, and this also we discussed. That is to reclaim the soils. Generally, I told you acidic soils. Generally, we add calcium and magnesium. That is limestone you add, and if it is alkaline or saline soil, generally you go for gypsum, etc. Thereby, you can reclaim the soil. Thereby, you add to the area which can be profitably used for cultivation. So this is about. So we discussed about agricultural meteorology, that is various climatic factors that affect your crop growth and yield. And then we discussed about types of soils. What are the different types of soils are there, and what are the plus and minus points of different soils we discussed. And the third one is different manures and fertilizers. So under this manures and fertilizers, we have seen the organic, inorganic, and green manures. And also we discussed about biofertilizer. Green manures and biofertilizer, I think you don't get confused. Green manures means green, that is leaves. Your Pangamia pinnata or Glyceridium or your sun hemp, Pilipesra, etc. The green leaves, branches, tender branches are plowed into the soil and made to rot, and thereby they add to the fertility. Then, whereas biofertilizers means here biological organisms, microorganisms such as rhizobium, your blue-green algae, or azotobacter, etc. These microorganisms are added in the form of seed treatment, or they are made. They are added to the soil. Thereby, they have the ability to convert atmospheric nitrogen into nitrate form. Those they add to the fertility of the soil. So with this our time is for 5 minutes. Doubt, and I'll try to clear your doubt. If you don't have any doubt, so let us meet on 10th Saturday at 12. From 12 to 1, we have second class. So thank you for patient hearing, and hope to see you next week. Thank you.